Hello everyone, happy to see you here. Today we have a great algebra question, a plus b equal to 20 and a product a times b equal to 24. We need to solve this question for a and b, so if you have your answer, your assumption, you can also write it in the comments below and then we will check our answer. So it will be really interesting to check our solutions, to check our answers in the end of the video. Of course, you can write your solution in the comments below. It will be really interesting. Okay, so first of all, we have a sum a plus b equal to 20, a product a times b equal to 24, and we need to solve this system of two equations. So what is the main idea? First of all, let's express from our first equation, let's express our b. This is our first step. So our b is equal to 20 minus a. This is our b from the first equation, so nothing hard. I hope you understand it. Right now we can plug in this b. Instead of this b, we're gonna plug in 20 minus a to the second equation. So let's do it. This is a classic method how we prefer solving this system of equations. So we have a times 20 minus a and equal to 24. Okay, this is our expression right now. Right now, let's simplify it. So we're going to multiply a by this parenthesis. So we have a times 20, or we can write 20a minus a square equal to 24. And if we look closely from a different angle, we have a classic quadratic equation, but we need to change in order a little bit. First of all, we need to write minus a square on the first position. On the second position, plus 20a, and on the third position minus 24 from the right side. So minus 24 from the right side, of course, equal to 0. What we're going to do next? Of course, we're going to multiply both sides by minus 1 because I like and I prefer when we don't have right here a negative sign. So I prefer a classic order of signs without a negative sign. So I prefer a clear x square or a square. So that's why we're going to multiply both sides by minus 1, a square minus 20a and plus 24. A classic quadratic equation. This is up to you how you prefer solving this quadratic equation. My quick tip, I prefer a classic method. First of all, I write on the right side our coefficients. So a equal to 1, b equal to minus 20, and c equal to 24. So we have all our coefficients on the right side, and I prefer starting a solution with discriminant. Okay, so we have d equal to b square minus 4ac. So let's check real quick our discriminant. So b square, we have minus 20 square minus 4 times 1 and times 24 equal to, okay, minus 20 square equal to 400 minus 4 times 24 equal to 96. So our discriminant is positive. This is really great. So 304, this is our positive discriminant greater than 0. So it means that in this branch we have two real roots. Yeah, two real roots. Okay, so let's plug in everything into this spot. So we have a first and a second equal to a minus b plus minus square root of discriminant and all over 2a. So let's plug in everything into this spot. We know everything. We know coefficients, we know discriminant. So minus b minus 20 and minus 20 right here, plus minus square root of discriminant, square root of 304, square root of 304, and all over 2a, 2 times 1. So equal to, and what do we have right here? Minus 20 equal to 20, so 20 plus minus square root of 304. The best way how can we express this 304? Of course, if you're not confident with it, so if you don't understand how can we express this 304, here is my quick recommendation. 304, I'm going to write it right here on the left side. So 304. How can we work with this value? How can we express this? My quick recommendation, just divide it by 2, we have 152. Just divided by 2, we have 76. Once more by 2, we have 38. And once more by 2, we have 19. And divided by 19, and we have 1. So basically 304, this is our 2 times 2 times 2 times 2. We have 16 times 19. Okay, 16 times 19 plus minus 16 times 19 and all over all over 2. And right now we need to know a really great property, because a square root of a product equal to product of two square roots. So that's why we can split it like plus minus square root of 16 times square root of 19. And right now square root of 16 we can easily simplify it, because square root of 16 equal to 4. So we have 20 plus minus 4 square root of 19 all over 2. And in the end, we're gonna cancel this 2 with this 2 in our numerator, but there are two ways how can we do this. Maybe the basic one is to factor this 2 from our numerator. In parentheses, we have 10 plus minus 2 square root of 19. 2 square root of 19 all over 2. And we're gonna cancel this 2 with this 2. As a result, we have 10 plus minus 2 square root of 19. This is our answer. Of course, there is another method. We're going to divide 20 by 2 and this expression by 2. We will have absolutely the same thing. Okay, so we have plus minus, and as a result, we can consider it as 2 branches. So first branch, a first, equal to, with the positive sign, so 10 plus 2 square root of 19, and another branch, a second, equal to 10 minus 2 square root of 19. And one really interesting moment, this is not our solution to this question, because basically we need to solve it for a and b, and from the beginning b equal to 20 minus 8. Don't forget about it. And right now we need to solve it for b first and for b second. So right now let's start it from, for example, b first equal to 20 minus a first, 20 minus a first, and the same thing right here, b second equal to 20 minus a second, Okay, right now let's plug in it. Sorry. We have b first equal to 20 minus a first, 10 plus 2 square root of 19. And we have the same thing right here, but first of all, let's simplify this expression on the left side. So b first equal to 20 minus 10 minus 2 square root of 19. 20 minus 10 equal to 10, so b first equal to 10 minus 2 square root of 19. And if you look closely, we have two symmetrical roots, b first and a first, so two absolutely the same constant, but with different sign. So it's really great. Right now let's solve it for b second. We also need b second. So b second equal to 20 minus a second equal to 10 minus 2 square root of 19. So b second equal to 20 minus 10 plus 2 square root of 19. And from here b second equal to 10 plus 2 square root of 19. Really great. So we have b second and we have a second. So we have absolutely the same symmetrical roots. So right now let's write our answer, and in the end we're going to check our roots real quick. So our answer to this question. So first of all, our first pair, a first, b first. So 10 plus 2 square root of 19 and 10 minus 2 square root of 19. And second pair, 10 minus 2 square root of 19. And 10 plus square root of 19, 2 square root of 19. Okay, this is our answer, and in the end, let's check it real quick. So here is our question, here is our proof, let's check it. So we have a plus b equal to 20, and ab equal to 24. ab equal to 24. Okay, let's check, for example, real quick, our addition. So we don't need to check both of these because we have absolutely two symmetrical pairs, and moreover, we have addition and multiplication. So addition, we can write a plus b as b plus a, so it doesn't matter what pair do we choose for here. And of course, a times b is the same as b times a. So this is not the great thing right here as well, because we don't need to check both of these pairs. So first of all, let's check real quick our addition. So a plus b equal to 10 plus 2 square root of 19 plus 10 minus 2 square root of 19 equal to. So this one we're going to cancel. 10 plus 10 equal to 20. And right now, let's check real quick our multiplication. So we have 20 right here and right here, so addition works perfectly. Right now, let's check real quick our multiplication. So our a times b equal to, let's check this as well. So we have 10 plus 2 square root of 19. We multiply it by 10 minus 2 square root of 19. Okay, right now we can also multiply this parentheses by this one, but this is a classic formula from school: x squared minus y squared. I hope you remember it. So we have x plus y and x minus y, and we have absolutely the same case. So x plus y, x minus y, but instead of x we have 10, instead of y we have 2 square root of 19. So that's why we can consider it as a difference of two squares. So we have 10 square minus 2 square root of 19. 2 square root of 19 square. Okay, so 10 square equal to 100. 100 minus 2 square. So we need to raise both these elements to the power 2. So 2 square equal to 4 times square root of 19 to the power 2 equal to 19. So I'm going to continue right here at this place. So 100 minus 4 times 19 equal to 76. So as a result, right here we have 24. And the same thing we have right here. So we have a correct answer, sorry. Yeah, so this is a solution to this question. We proved it, we solved it, and of course, if you still have any problems, if you still have any question, write your question in the comments below. It will be really interesting to read about it. Also, write your thoughts about it, write your approaches. What do you think about this type of question? Write your solution. Maybe you have your own way how you prefer solving this type of question, because this is my approach, a classic method, because maybe a lot of students here, they struggling with the basic math, with the algebra concept. So that's why I use a classic method of substitution, a classic quadratic equation. I don't use a theorems, I use a classic method discriminant. Yeah, and you know, I just want you to understand how we prefer, how we solve this type of question. So thank you everyone for your time. Take care of yourself. Have a great day. Also write your thoughts, write your response. Want to say thank you for watching. Thank you for being here, for supporting my channel. I really appreciate it, and it's extremely helpful for me. And it inspires me a lot to make new content every day, because my main goal here is to make math clear and understandable for everyone. And I really hope you'll learn something new. You'll learn maybe a formula, or you'll learn a trick. It's also really great. So wish you all the best in your life. Take care of yourself. Have a great day. See you in the next videos.